Welcome to this video on binomial distributions. By the end of this video, you should be able to determine whether the conditions for a binomial setting are met and calculate the mean and standard deviation of a binomial random variable and interpret these values in context. So, for today's scenario, we're going to take a pop quiz. I hope you're ready. The quiz consists of 5 multiple choice questions. Each question has 4 answer choice, labeled A through D. Now for the bad news, you will not get to see these questions. You will just have to guess the answer for each one. So go ahead at the top of your paper, answer the 5 questions. When you're done, come back to the video. Alright, here are your correct answers. How many did you get correct? Go ahead and write that number right here. So, we're going to use the random variable x to represent the number of correct guesses. Is this a binomial setting? So let's take a look. That's our bins, remember? B-I-N-S. So is this binary? It is, because we have a success would be a correct answer, and a fail would be a wrong answer. So we're good there. We have a binary scenario. Are these independent? Each answer does not affect the other, so they are independent. Okay, so we're good there, 2 out of 4. Now, is there a set number of trials at the beginning? Well, there are 5 questions, so your n equals 5, so we're good there. And finally, is the probability the same? The probability of success the same each time? Well, each answer has 4 choices, so the probability of success is 0.25, so that is the same each time, so this is a binomial setting. All right, so what we want to do is we want to calculate the probability of getting exactly 2 questions correct. Okay, so we're going to use the formula from yesterday. So we have the random variable x, so we want to say the probability that we get exactly 2 questions correct is, so going back to the formula, there's a total of 5 questions, and we want to know about getting 2 of them correct. And the probability of success is 0.25. We want 2 of those, and the probability of failure is 0.75, and that means there's going to be 3 of those because we have a total of 5 questions that we're talking about. So take a second, calculate that answer, see what you get, and come back and check. All right, I got 0.264 for my answer. So that means there's about a 26% chance of getting exactly 2 questions correct just by guessing. So what I want you to do is I want you to go through and I want you to calculate each of these probabilities using this formula. So it will be 5 choose 0, 5 choose 1, 5 choose 2, and so you'll replace this bottom number each time. We already know this one is 0.264. So go ahead and find the rest of the values, come back when you're done, see how you did. All right, so here are the probabilities I've gotten. Hopefully you got the same ones using the formula. Now, we want to find and interpret the mean of the distribution. I want you to show your work. Now, we have a random variable and its probability. So you know how to do that using your calculator. So go ahead and make sure you do that. Standard deviation. Be sure to interpret both of those. Go and work on those too and come back when you're finished. Okay, let's see how you did. So we can calculate the mean in the calculator, but if you have something that says you got to show your work, you want to show your setup. So this was our expected value. You took the value times the probability plus the value times the probability. I didn't show all of them. That's what the dot 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 in the middle is, but I'm showing the reader that I know where my numbers are coming from, and I got 1.25. And the interpretation is after many, many quizzes, remember this is a long-term probability, after many, many quizzes, the average was 1.25 correct out of 5. Be sure on these, you got to say what it's out of, because we know the set number of trials ahead of time, so be sure to include that piece of information. And then for our standard deviation, it didn't say show your work, but this is still coming when we did our expected value from our means. So I showed the setup and I got 0.969. And so the number of correct on a 5-question quiz typically varied by 0.969 from the mean of 1.25 correct. Somewhere along that line that you're telling me, here's a 5-question quiz, there's the variation of this in comparison to the mean, and have your context in there also. All right, so hopefully that went pretty well for you. Let's take a look at 7. We want to know the probability of getting at most 3 correct. So the probability of x at most means less than or equal to 3. So the way we can do that is we're going to add all the ones up that are less than or equal to 3. So we got, and if you're going to put it in a calculator, you should write it down. 0.237 plus 0.396 plus 0.264 plus 0.088 for a total of 0.985. Okay, so the probability of getting at most 3 correct is 98.5%. Okay, so what is the probability of getting 3 or more correct? So the probability of correct needs to be greater than or equal to 3. And so that is 0.088 plus 0.015 plus 0.001, and I got a total there of 0.104. All right, so what I want to do here is I'm going to tell you some information on how to make this happen in your calculator. So you're not having to do a probability distribution each time and then doing all of this by hand, okay? So the one thing I want to show you, let's start back up here on number 3. So we're going to use our calculators. So make sure you have it in front of you. All right, so here's my calculator. What I want you to do is right here above the word VARS, it says DISTR, distribution. We've been talking about distributions this whole time. We've been using a binomial distribution. We've talked about normal distribution, a sampling distribution. We've talked about all these different distributions. So we want to go in there, so we got to hit the second button and then VARS. Okay, and you can go up or down. I usually go up, it's a little bit closer. And we're going to go up, and we have this binom, and there is so that stands for binomial, and there's a PDF and a CDF. Right now I want you to just pick the PDF, and I'll explain it to you in just a second. Now mine shows all of this laid out, so yours may not, and so we'll have to deal with those individually. So we had, for this scenario, we had 5 questions, so there's 5 trials. The probability of being correct was 0.25, and we wanted to know the probability of getting exactly 2 correct. So for a lot of you, you're going to get the word binom, PDF, and then a parenthesis. So you'll put the number of trials, the probability of success, and which number you're looking for in there. And we're going to press enter. And look, we got 0.2636, which is, we rounded to 0.264. So let me show you for the calculator We can use this on the AP exam if we are careful here. So what we're going to do is we're going to say I'm going to use the binomial PDF, and in that I have to put the N for the number of trials, P for the probability, and X for the number of successes that I'm looking for. And what that looks like with the numbers plugged in, it looks like this. So 5.25 and 2. So you have to have all of your numbers plugged in. And I'm labeled what they are. The other option is you can write this and write NPX over the top of it, and you can skip this first part, but you should still have the probability of X equaling 2. And that's going to equal 0.264. So you get the same answer, it just does it for you. Okay? So when we were looking at it, there were two binomes. There was the binomial PDF and the binomial CDF. We're going to end up using both of these, and here's where I want you to make a little note. The PDF is for an exact number. If I say I want to know if it's exactly 2, exactly 3, it's for an exact number. The CDF is for a range of numbers. And that's when you're going to be using your inequality symbols. Okay? So PDF is a particular exact number. CDF accumulates, it adds them all together for a range of numbers for you. So let's kind of look at this. So let's look at number 7. I have a range of numbers because I said at most 3. Okay, so I wanted to know these numbers right here, just through 3. Okay, so what we want to do is I want you to go to your binomial CDF. So I'm going to use my same notation. The probability that X is less than or equal to 3 equals, I'm going to do this the longer way. If you choose to do the shorter way like I showed right here, that's fine. Binomial CDF, and we're going to input N, P, and X, and it's going to look like this. 5, our probability is 0.25, and I want to know all the way through 3. Okay, and I'm still going to get the same answer. The shortcut is you could have just written just this piece and put N, P, and X. If you don't label them, they will take off points on the AP exam. So I'm being very specific here that you have to label them. Okay, so what the binomial CDF is it took all of these numbers and then added them together for you. Okay, well, let's take a look at number 8, and let's try this going the other way. The probability of X being greater than or equal to 3 equals, so we're going to do a binomial CDF, and you got to input N, P, and X. Now this is going to take a little bit of thought. All right, before I write the rest of this, I want to go back and look at this list. I want 3 or more. 3 or more. So I want those numbers. So the way the CDF works is just like on your normal curve, it only adds the lower part of the numbers. So when I asked this less than question, it was really easy. We just said, oh, we want to add up through where X is 3, and it just added them up for us. It won't, if you just say, I want to know what 4 and 5 are together, it will not do that unless, I'm hoping you're realizing, this equals 1, just like all good probabilities. So if I take 1 minus the lower section that the CDF will give me, it will tell me what's left over for the upper section. So I'm actually going to write 1 minus binomial CDF. Okay, now let's keep thinking. We had 5 questions. Their probability is 0.25. Now I need to know, what am I adding up through? Because I really want to know about 3, 4, and 5. What are they together? So that means I need to add 0, 1, and 2. So I'm going to accumulate through the number 2. Okay, and when I do that, I should get the same number of 0.104. All right, so if you're wanting to know a greater than, you got to use 1 minus, because just like when we're talking about on the normal curve, it only shows the lower shading area. This does the same thing. So if you want anything that's greater than, you got to do 1 minus to get the number. Okay, so we're not quite done with our notes here on the front. Here on our mean, we did our mean just like we were doing before for our expected value. Well, we can do this a little bit shorter. What's nice is if you have a binomial setting, so this only is true for binomials, you can say the mean is n times p. Okay, so our n here was 5. Our probability was 0.25. And when I multiply those together, I get 1.25. All right, so if it is a binomial setting, you can use the shorter version, but obviously the longer expected value also works. Okay, and also for our standard deviation, for a binomial setting, can be n times p times 1 minus p. So let's think about what that means. I want the square root of the number of trials times the probability of success times the probability of failure. So in this situation, we had 5 trials because there are 5 questions. The probability of success was 0.25 and the probability of failure was 0.75. And you'll still get the same answer of 0.969. All right, so let's flip this on over and do some summarizing of what we just talked about. All right, so the first thing we want to look at is describing a binomial distribution. We've already been describing them some when we're checking our bins. Okay, the other thing we want to do is we want to look at the shape of our distribution so we can make a histogram. And I'll show you how to do that. Okay. We want to look at the center. Mention the center is your mean. So really like we've been doing since Unit 1. And then your variability, you want to look at the standard deviation. All right. So that's if we want to describe it. Let me give you some interpretations for the mean and the standard deviation. Okay, for binomial distributions, to find the mean, remember, to find the mean of whatever random variable they're asking for, all you have to do is n times p. Okay, then we have our interpretation of this. So after many, whatever it is, so many, and I must say whatever the context is, context trials. Okay, the average number, fill in the blank, and I'll come back and fill in these blank, is blank out of blank. Okay, so we want to, so after many, whatever the context is, trials, the average number of context successes is the mean out of the total number of trials. Okay, So after many trials, context trials, make sure you put what it is about. The average number of context successes is the mean out of the total number of trials. Okay, then we have our standard deviation in a binomial setting will be the square root of the number of trials times the probability of success times the probability of failure. Okay, and you'll take the square root of that. So, to interpret this, we're going to say the number of blank, we'll fill that in a second, typically varies by blank from the mean of blank out of blank. So hopefully you're kind of getting the idea of what's going to go in there as I'm saying the words blank. So we have the number of success contexts. It's really no different than what we've been saying, but the big one is this right here at the end. So it typically varies by whatever our standard deviation is from the mean out of your total trials. And this is the newer part. I want to be sure that you include that in there. All right, so for the check your understanding, I want you to try this on your own. Check your bins here. So use technology to make a histogram. So there's a couple ways to do this. There's an easier way and there's a harder way. And I actually kind of prefer personally the harder way. But so we're going to have, this says we're going to pull 10 slips out. Okay, so when we make this, our X's are 0. We could have 0 slips. We could have 1 slip, 2 slip. You're going to want to go all the way out to 10. Okay, all the way up to 10. Now on the side you're going to have your probability. So I usually count by 5s if I can. You're not going to have anything above 0.4 on this one. So the easier way is to go into Stat, Edit. Now I'll go ahead and delete this out so you can see what happens. I put all of my options in here. I can have 0 papers to 10 slips. Okay. I'm going to highlight L2. And I'm going to go in and we're going to do a PDF because we're going to use these particular numbers. I'm going to say, go into my distribution, and I'm going to pick a binomial PDF. I'm going to have 10 papers that are drawn. The probability of drawing each of these papers is 0.25. And for the X values that I want plugged in, they're actually in, nope, they're in list 1, sorry. Okay, because that's where we put our X values. 0 pulled, 1 pulled, 2 pulled, 3 pulled. Okay, and I'm going to paste this in, and it's going to give me all of the probabilities right there. So right there, I personally would make my probabilities off of that. I would say, oh look, the first one is 0.05. So I would say 0.05. Okay, the next one is 0.18. So then I would come up and I would do 0.18. Okay, that's what I would do. You can make your graphing calculator graph this for you. It just tends not to look as good. And so I'll show you what I mean. So we can go into stat plots like we used to. I want to do a histogram, which is right here. My X's are in list 1 and the frequencies are in list 2, and I'm going to tell it to graph. Now, a lot of times when you get this, it's zoomed way out, so you want to look in your window to make sure you're counting by ones. But I'm going to say I think it looks a lot better if you just use your probabilities from your list to graph it from here rather than actually graphing it and copying it from your calculator. You'll get a better representation. Okay, so you'll just go through here and you'll graph all of these. So you can do that first, so then you always know how high you have to go on your probability list. So give this a try, come back when you're done. All right, let's take a look at part A. Part A, I've got my bins here. Success is a win, fail is a lose, so we're binary. Independent, the slips of paper are replaced before the next drawing, so the probabilities are not changing, so it's independent. There's a set number of trials of 10, and it's got the same probability of success each time because we're replacing the paper. Okay, remember how I said previously that your independent and your same probabilities are related to each other. So you have a probability of 0.25, so we have a binomial setting here. So remember I showed you how to get these numbers. Here's what my graph looked like doing this by what is in your table here. But look how it looks different than the actual graph that your calculator makes, because it makes different bin widths and ranges. And I think this is a better representation. Okay. And you have all the numbers, so it's not really taking that much longer. So describe the shape. It's skewed right, and there's a peak at 2. All right, to find my mean, I took n times p, so I got 2.5. So after many, many random drawings of 10 slips of paper, the average number of winners is 2.5, or somewhere along there. You know, it's not word for word to our interpretations that I showed you above, but it includes all the pieces. And then for our standard deviation, n times p times 1 minus p, I got 1.37. So the number of crinkled papers selected in a set of 10 typically varies by 1.37 from the mean of 2.5. So I included the out of up here. I didn't put it at the end here. It just felt like it would flow a little bit better up there. So hopefully that was helpful. Let me know if you have any questions. See you in class.